All right, so today our objective is that we're going to know our inverse operations and can use them to solve one-step equations. So today should be review. You should have done this in 6th grade and 7th grade, but I want to get our toes wet and start working on these inverse operations to make sure we have a solid foundations for when our equations get more difficult in 8th grade, because they will. You'll see a little bit more than you have the past couple of years. So let's get started. So these are our steps in order to solve a one-step equation. You'll locate the variable. We know that a variable is a letter that takes the place of a number. You want to underline that and draw an arrow or something and put variable is a letter that holds the place of an unknown number. Know that, but that's a good thing to include. So let's put that. I'm going to put that here, but if you do not have room, you can draw an arrow and put that definition to the side somewhere. That's what our variable is. And then once we've done that, we have to determine the operation that's tied to the variable. And we know our 4 choices are subtraction, addition, multiplication, or division. So then we're going to use our inverse operations on both sides of the equal sign to solve. Check your solutions. If you need to pause that, put the definition and those operations in, you can. So let's talk about what our inverse operations are. So our inverse operations can be used to solve the equation because they undo each other. So multiplication is inverse with division, and vice versa. Division is inverse with multiplication. And so then same thing with addition and subtraction. Addition is the inverse of subtraction and vice versa. Subtraction is the inverse of addition, and they are used to undo each other. If you want to pause that and fill that in, you can, or you should, so that you have that written down. All right. So let's work through a couple of examples. On this one, I have addition. We just determined that my inverse of addition is subtraction. So in order to get that plus 7 away from the x, I'm going to subtract 7. But equations are like a balance scale. And it's easier for me to go ahead and show you. But if you have a balance scale, I have a set weight here and a set weight here. In order to keep that scale at the same level, I have to move the same amount. So if I take 7 from the left, I have to do the same thing to the right in order for this equal sign to remain true. So if I take 7 from the left, I have to take 7 from the right. So we know that 7 minus 7 is simply 0. So you could say x plus 0 and then drop the 0. Because anything plus 0 is itself. And then that is equal to negative 1 minus 7. So make sure you say plus a negative, because we know keep, change, change. And I have negative 1 plus negative 7. And our property for that, or our rule for addition of integers, states that if I'm adding 2 negatives, it's going to become a bigger negative. So 1 and 7 make 8, so bigger negative. So same thing here. On 2, I have subtraction now. My inverse of subtraction is addition. So to get rid of minus 11, I have to add 11. And still, like my balance scale, because that says it's equal, what I do to one side, I have to do to both. So I'm going to add 11 to both sides. So this cancels, and I'm just left with 1, because negative 11 and positive 11 is simply 0. So I have m equals, I have negative 9 plus positive 11. When I have a positive and a negative, our rule is that we subtract and keep the bigger sign. So 11 minus 9 is 2. And 11 is larger than 9, so we're going to keep the positive of the 11. So positive 2. All right, on 3, I have addition. Our inverse of addition is subtraction, so we're going to subtract 14 from both sides. 14 from the right side, and 14 from the left side. So on the right side, we're left with h. And then we have 9 minus 14. So again, a positive and a negative. We're going to subtract to keep the bigger sign. So 14 minus 9 is 5. And 14 is bigger than 9, so we're going to keep the negative sign. All right, and then we're going to do the same thing on this fourth one. I have negative 15 plus w equals 14. So we have addition. Our inverse of addition is subtraction. So I'm going to subtract negative 15. Make sure we're subtracting the same thing. So minus and negative is the same as plus, and a positive and a negative subtract to keep this bigger sign. Negative 15 and positive 15 is 0. So again, minus negative 15, which is the same as keep change plus a positive. Make sure if you are subtracting that negative 15. So now I have two positives, so w equals 29, because 14 and 15 give me 29. Perfect. All right, if you need to pause this and finish copying work, you can. I want you guys to go ahead and do these two on your own. Pause this, work these two out, wait for me to finish, and we'll go through them together. All right. Have you done them? You're still listening to me? Pause this, work them out. All right, so by now you should have already paused them. On this first one, I have subtraction. What did you use to get rid of subtraction? That's right, addition. So I have minus 8, so I'm going to add 8 to get rid of subtraction. And because it says it's equal on both sides, what I do to one side, I have to do to the other. So we're left with k on the right, because negative 8, we did plus a negative. Negative 8 and positive 8 are cancel out to 0. So now I have negative 21 and positive 8. And I have a negative and a positive. I'm going to subtract to keep a bigger sign. So 21 minus 8, 11 minus 8 is 3. 1 minus nothing. So I have 13. So now I have negative 21 and positive 8. Which one is bigger? Right, negative 21. So we're going to be left with negative 13. All right, so did you get that right? Awesome. If not, bring those questions to a small group. Awesome. All right, so on this next one, we have addition. How do we get rid of addition? Subtraction. Remember, you are subtracting negative 4. So minus negative 4. So plus a positive. When we do our keep change, positive and negative cancels to 0, and you are left with v on that right side. Same thing on the left side. Negative 1 plus a positive, because minus a negative. So just so we can see that. Minus negative 4, which becomes plus a positive when we do our keep change. I have positive 4 and negative 1. We're adding a positive and a negative. We're going to subtract and keep the bigger sign. 4 minus 1 is 3. Positive 4 is bigger. Did you get that right? Awesome. If you didn't, do you see what you did wrong? Did you just subtract 4? Did you not do minus a negative? If you don't see what you did wrong, please bring those questions to our small group. All right, let's do a couple of examples with multiplication and division. Same thing, multiplication gets rid of division and division gets rid of multiplication. And when I have a variable next to a number, that implies multiplication. So if I look at 7, I have 4 times a equals negative 24. So in order to get rid of multiplication, I have to do division. So divide 4. What I do to one side, I still have to do to both. 4 divided by 4, 4 over 4 is simply 1. So we have 1a, or a, equals negative 24 divided by 4. Well, 24 divided by 4 is 6. And a positive and a negative is going to give me negative. Same thing on 8. I have negative 56 equals negative 7p, or negative 7 times p. So to get rid of multiplication, we're going to divide by a negative 7. Negative 7 over negative 7, those two negatives would cancel each other to positive. 7 divided by 7 is 1. So we're simply left with 1p, or p, equals, and what I do to one side, I have to do to both. So negative 56, that line means division, divided by negative 7. Well, let's ignore our signs for a second. I know 56 divided by 7. What times 7 gives me 56? 8. And now let's think about our signs. I have two negatives. When I'm multiplying and dividing with two negatives, am I going to get a positive or a negative? That's right, a positive. So, positive 8. All right, so 9. I have so many people all the time go, Ms. H, I can't do this. This is fractions. That line under that N means that this is division. So N is being divided by 5. In order to get rid of division, I have to multiply. So I'm going to multiply both sides by 5. So I have 5 over 1. So when I multiply straight across, you'd get 5n over 5. 5 over 5 cancel to simply 1n. And then we're going to do the same thing to the other side. Times 5. 9 times 5 is going to give me 45. We're simply left with 1n, or n equals 45. Same thing over here on 10. R is being divided by negative 8. In order to get rid of division, I have to multiply. So I'm going to multiply by negative 8. So I'm going to put it over 1. So I have R negative 8 over negative 8, which cancel out to 1. So 1R. And then what I do to the right side, I have to do to the left. I have 2 times negative 8 gives me 2 times 8 is 16. And a positive and a negative is going to give me a negative. So I'm left with negative 16 equals 1R. Remove this. If you need to pause this or write this work down, you can. All right. I want you guys to do these two on your own. And then I will go through them with you. Let me give you a hint on this 11. We know there's an assumed 1 here. I want positive k, not negative k. All right, pause it. Work it out now. By now you should have paused it. You're unpausing it. All right. So on 11, you might have said 11 is done. I have negative k. Remember, I want k, not negative k. So k is being multiplied by the assumed 1 there, so negative 1. So I'm going to divide both sides by negative 1. And negative 1 over negative 1 is simply 1. So 1k. And then 7 divided by 1 is 7, and a positive and a negative are going to give me a negative. So k is equal to negative 7. Did you get that? You didn't, it's okay. We'll do some more of these in our guided practice. This is one that always throws people. All right, we might star it. All right, so then on 12, I have x divided by negative 6 equals negative 12. We know that that line means that's being divided. How do we get rid of division? That's right, multiplication. So we're going to multiply both sides by negative 6. So times negative 6. All right, and then I have negative 6 over negative 6x, which this cancels to 1, which is negative 6 divided by negative 6 is just 1. 6 divided by 6 is 1, and a negative give me a positive. So 1x. Same thing. Okay, so now I have 6 times 12. 6 times 12 gives me 72. A negative and a negative give me a positive. So I am left with x equals 72. Did you get that? Awesome. If you didn't, that's okay. Please, please, please bring me questions. I have answers. Come to guided practice. I will help you. All right. So today we talked about our inverse operations. We said that multiplication and division are each other's inverse operations. To get rid of a variable being multiplied by something, you divide by that number. In order to get rid of a variable being divided by something, you multiply by that number. Same thing with addition. In order to get rid of something being added to a variable, you subtract. In order to get rid of a variable being subtracted by something, you add. All right, I want you, when you turn these guided practice notes in, to do these 4 problems. I'm going to go back and check those. So I'll be looking that you have those inverse operations in those couple I did, but I will definitely be looking for the fact that you did these 4 on your own without me going over it, because I know when I go over it, you can just copy and not pause it. So I'm gonna look at those. Otherwise, if you're happy, you're great. Turn in these guided notes. Do the work on Schoology. Otherwise, please come to our guided practice. And that's all I have for you. Have a great day, guys. Bye.